A line graph is a graph that uses line segments to show how data changes over time. I'm sure you've seen a line graph before and you don't really even realize it. A lot of times it's really common to see in like science classes and things like that. The series of numbers placed at fixed distances that label the graph are the graph's scale. The interval or difference between one number and the next on the scale should be equal. So today you're going to use your knowledge of ordered pairs and coordinates to learn about line graphs. So we're going to work through this unlock the problem. As you'll see, there is a table here. It's recorded temperatures. It's got the time as well as the temperature at each time. Use the graph to determine the times between which the greatest temperature change occurred. Right over to the right, you'll see write related number pairs of data as ordered pairs. So right here, you'll already see 1 o'clock and 51 have been written. So we can do 2 o'clock and 49. We can do 3 o'clock and 47. We can do 4 o'clock and 44. 5 o'clock and 45, 6 o'clock and 44, and 7 o'clock and 46. And so we know what ordered pairs are. We've worked really hard to learn what those are. So those ordered pairs are really easy to write. Now, when I was reading those definitions like scale and interval to you at the beginning of the lesson, you might have thought that I was speaking Spanish. But this is where the scale comes into play. So we have our horizontal axis where we write our time. That's why up here, the time is written first. So the time is on top on our recorded temperatures. So the time is our x-axis. So we wrote the time first here. So then when I go to make my chart of the recorded temperatures, I stick my times down on my x-axis. I stick my temperatures up on my y-axis. So for the vertical axis or the y-axis, choose a scale and an interval that are appropriate for the data. You can show a break in the scale between 0 and 40 since there are no temperatures between 0 and 44. And what that means is you have to take this chart and make a scale on the left side. Now, you always have to have an origin. You always have to have a 0. But rather than going up like 2, 4, 6, 8, 10, 12, you don't need to go and waste all that space because you don't need anything between 0 and 40 because there's nothing between 0 and 40. Now the first one is 44. That's our smallest one. But you don't want to start necessarily the smallest one and it be shoved all the way at the bottom. You start close to it. And then you pick an interval that is appropriate. So looking at these numbers, I've got 44, 45, 46, 47, 49, and 51. It's not going to be appropriate to go up by 5s because you're not going to be able to accurately see the data. These numbers are so close together, you could go by 2s or you could even go by 1s. In our math text, they have decided that they're going to go up by 2. So they start the 0 and then 40. And then it goes up by 2s each time, 42, 44, 46, 48, 50, 52, and 54. So they chose their scale and they chose their interval there. Hope that makes sense. And I already went over the horizontal axis with you where we simply write the times. Then graph the ordered pairs. So let's get to graphing. Remember, the time is the x-axis, okay? The temperature is the y-axis. That's already been written there for you. So I've got 1 o'clock, and 51. That has been labeled. Now I have 2 o'clock and 49. That has been labeled. Notice how there's not a 49, guys, but 49 goes between 48 and 50. So you simply stick that dot in the middle of the line. Now we have 3 o'clock and 47. There's no 47, but we know it falls between 46 and 48, so I can simply stick it in the center. Now I have to do 4 o'clock. 4 o'clock hasn't been done for me yet. 4 o'clock is 44, so I go over and find 4 o'clock, and I go up until I see 44. 44. You can go ahead and connect those because that is how line plots are different. You're actually connecting your points. It helps you see the change in data. Now for 5 o'clock, I have 45. 5 o'clock, go all the way up to 45. There is no 45, but I need to stick it between 44 and 46. Right there. And so I'm seeing a change in my data a little bit. I'm going up. I'm starting to go up. Now I have 6 o'clock. 6 o'clock, 44 again. So I come all the way over to 6 o'clock. I go up to 44. So I'm coming back down again. And now I have 7 o'clock. 7 and 46. So 7 o'clock, and I need to go up until I see 46. All right, so that is how you graph your recorded temperatures. That's how you would graph your recorded temperatures. You put the time, that is the x-axis, you go over, and then you go up, just like you would on any coordinate grid. So now to answer the question, I'm trying to see where the greatest temperature change was. And this line graph really helps me to see that. So I'm looking and I see that this is 51 and this is 49. So that is a difference of 2 degrees. Now I go from 2 o'clock to 3 o'clock. I'm going from 49 to 47. That is a difference of 2 degrees. Now I'm going from 3 to 4. From 3, we have 47. At 4, we have 44. So from 47 to 44, I have a difference of 3. Now I'm going from 4 to 5. At 4, I have the temperature is 44. At 5, the temperature is 45. That's only a difference of 1. From 5 to 6, I look at 5, it's 45. 6 is 44. That's a difference of 1. I look at 6, it's 44. 7 is 46. So that is a difference of 2. So my biggest difference is the one with 3, and that is between 3 o'clock and 4 o'clock. And that is why line graphs are so cool, guys. You're able to visualize where the biggest difference is. Because if you'll look at these, I definitely see my biggest line between 3 and 4. All right, let's talk about another problem. In this Try This problem, Jill used a rain gauge to collect data on the total rainfall during 6 days at her home in Miami. She read the amount of rain collected in the gauge each day and did not pour it out. Her data is shown in the table. Make a line graph to display Jill's data. So the step 1 is to write related pairs of data as ordered pairs. And to do that, remember, we're writing our day as our x-axis, and we're writing the rainfall collected in inches as the y-axis. So Monday, 2 is already done for you. Tuesday, 2. Wednesday, 3. So we write Wednesday, 3. Thursday, 6. Friday, 8. And then Saturday, 9. Now we have to choose a scale and an interval for the data. Well, looking at this, my smallest amount of, maybe I can talk today. Looking at this, our smallest amount of rainfall collected is 2 inches. Our largest amount of rainfall collected is 9 inches. So I think we can make our scale from 0, because we have the origin, from 0 to 10. What do you think? Because it gives us a little bit of space before and a little bit of space after, and all of our numbers fit within that scale. And then we have to determine our interval. So you can go up by 2. You can go 2, 4, 6, 8, 10. Or you can go up by 1. I always think that if you can, you should go up by 1, but it's really up to you. It's whatever you want to do. So I'm going to make my interval, that's my scale. I'm going to make my interval 1. Because I'm going up by 1. I could make my interval 2 and go 2, 4, 6, 8, 10. It's up to you. So now I have to label the horizontal and vertical axes. Write a title for the graph. A lot of times when you write a title for the graph, you just use the same title that's on this chart. So you would just do the rainfall collected. Rainfall collected. Remember that your days are along the bottom because that's the x-axis. Your rainfall is along the side because that's the vertical axis. So I have 1, 2, 3, 4, 5, 6 days. 1, 2, 3, 4, 5, 6 days. Just because these boxes are really small, I'm going to go ahead and make it like 12 and skip 1, if that makes sense. So 1, 2, 3, 4, 5, 6. And then I'm going up by 1 each time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now I need to label my days. So I'm going to start with 0 right here because that's the origin. Day 1, Monday. Just for time purposes, I'm just going to put a letter. Skip 2, Tuesday. Skip 2, Wednesday. Skip 2, Thursday. Skip 2, that's Friday. And skip 2, it's going to give me Saturday. All right. And now I said that my interval was going to be 1, so I'm just going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So, and then you can just like expand it out a couple more and then go ahead and close it off. And remember, when we're dealing with a line graph, we have to label our axes. So we don't just put x-axis, we have to put what the x-axis represents. Represents the day. That looks like pay, I'm sorry. I'm a mess. And then I have to put my my y-axis label on the y-axis. I don't just put y-axis. And that is rainfall. And then I have to put in inches. So remember, the x-axis, you just put what is the x-axis. For the y-axis, you just put what the y-axis is. So now let's get to graphing. Monday, 2 inches of rainfall. So I go to Monday and I go up 1, 2. Tuesday, 2 inches of rainfall. I go up 1, 2. And remember, with a line graph, you connect them. Wednesday, I go up 3. 1, 2, 3. Thursday, I go up 6. 1, 2, 3, 4, 5, 6. Wow, big change there. Friday, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then Saturday, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and now I just go down and I answer the questions based on my line graph. On which day was the total recorded, I guess I can't read either. On which day was the total rainfall recorded the greatest? So the most rainfall we got was 9 inches, and that was on Saturday. So that is the day with the greatest amount of rainfall. And then on which day did Jill record the greatest increase in rainfall collected from the previous day? So that's the day with the biggest change. So between what 2 days was the biggest change? This has no change. This has a change of 1. This has a change of 3, a change of 2, and a change of 1. So the biggest difference is definitely between Wednesday and Thursday. So the biggest increase was Thursday, from Wednesday to Thursday. Because on Wednesday, there was only 3 inches, and then on Thursday, there were 6 inches. So that was the biggest increase.